The two part we completed, right guys? The measures of central tendency, and we introduced two measures of offline team. Don't you understand, guys? Mean, median, and mode. Okay, we already done this. And then measures of asymmetry. Is it asymmetry? Yep. Okay, asymmetry. Just go here. So skewness and curtoise, isn't it, guys? So what is range of curtoise? Minus, oh, minus 3 to 3. Okay. Yeah. Let me copy. And positive skew when we get, when mean is greater than median and mode, then we get positive skew, negative skew, and I'm sorry, mean greater than median and mode. The data is left and outlier is at right. So we got positive, negative, and zero skew. We done this, isn't it? Okay. And this also we covered yesterday. Okay. Why F2? Oops. F2. 1 second. Okay. And also, how many library yesterday we introduced? PyTube 3 and YT hyphen D download DLP. DLP or DPL? DLP. We done two libraries, and we completed YouTube video downloader projects with simple functions and conditional statements, guys, and conditional statement, right? These things we done. Okay. Copy, then move here. Today's is 29, 34. Okay. Minimize. Let's go ahead. Do you see we build the dashboards later, not right now? Just build these dashboards later. Okay. Which distributions always we need to consider, guys? Normal distributions. Okay. Today's date is 29th, and okay. Yeah, this part. Copy and paste here. Good. Minimize. Okay. Let's start today's session. So the agenda for today's session is, the first thing, today I will complete descriptive statistics. Today I will complete descriptive and introductions to inferential stats. Two things. Then I will give you interview question bank for conditional statement, along with some patterns, all those things. All right. And after that, I will give you statistics interview question, statistic interview questions, and statistics PDF, which is very important. PDF, which is very important. And then I'll introduce to functions. For loop, while loop, are we done or not? Yeah. So these things are agenda today. Clear? First, descriptive statistics, introductions to inferential. I will share conditional statement, statistical interview questions, and document to prepare formulas, and some notes to understand. Then we'll introduce Python functions. Okay, these things. Good. Let's start today's sessions now, guys. Okay, minimize. So in descriptive statistics, how many parts we completed? 2 part. Let me finish the another one. Okay. This is skewness or not? Skewness, we already discussed. Do you see? I mean, here, this is positive skew or negative skew, this graph. This graph is positive or negative, guys? Positive. How do you know? The outlier is at right side. Okay. Data is at left. Okay. Now, today's session, understand measures of variability. I'll go ahead and write down. Let's introduce measures of variability. This comes under descriptive statistics. In this measures, we has three concepts. The first one, do you see this, guys? In descriptive statistics, this two part we completed or not? In descriptive statistics, yesterday we completed three part. Today we complete. In here, variance, standard deviations, coefficient of variations. Just go ahead and write down this one. The first one, variance. Second one is standard deviation. Third one is coefficient of variations. Okay, now let's understand. Go to the documents. The first one, variability. The first concepts of variance. Everybody joined online team? Okay, so this is population or not? And this is sample. From the country, if we bring the small piece, this is called sample. Okay. All right. See, do you know the mean formula? Population mean, sample mean. Understand? So, population's mean we call as not meow, it's mu. It's mu. Okay. And sample mean is called as X bar. Okay. So, how do you write down? Mu, isn't it? And this is X bar. Understand these symbols. This is symbol everywhere. It is constant. Understand? Addition means plus everywhere or not plus. Subtractions means minus everywhere. The same way. Populations mean, that means it's mu, and sample mean, that means X bar. Clear up to this? Okay. Now, so the formula. So I told you population, do you see summation n I equal to 1 xi? I think you already know this, but again, 1, 2, 3. This is x1, x2, x3, dot, 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 xi. Can I say this? And then summation ni equal to 1. So the meaning of this equals to x1 plus x2 plus x3 divided by 3. So that's the way we represent this formula. In data science, only 10th class mathematics and plus 2 class maths is required. If you know it, that's damn good. If you don't know, I will cover it, but no need to worry. In interview, no one asks, give me the population formula. Understand him? In interview, nobody asks the formula, but to understand, just remember this one. Population mean, we write down mu. This would be X bar. Pretty clear? Okay, that's good. Next one. Variance. Variance means the data spread towards mean. Understand everyone mean? The variance means the data spread towards mean. What is mean by that? Let's understand. Variance is divided into two parts. Population mean, population's variance. Okay, guys, just go here and I will mention as population, variance, and sample variance. Population variance, we call this symbol as sigma square. So population variance, we call this sigma square. Sample variance, we call as S square. Sample variance we call as S square. Understand? This is, I'm not creating, this is the statisticians, they already created the symbol long ago. Whatever they created, we just follow the footprint. That's it. Understand, team? So population mean formula, mu. Sample mean, X bar. Population variance, sigma square. Sample variance, S square. I will share, Venu, I will share. So I need any volunteer to write down all the formula. So if you guys maintain the formula sheets, every day maintain the formula sheets and post if you want it. Are you clear? So this is all comes under data science formulas, guys. This is all comes under data science formulas. Okay. Next. So I know you not understand these equations, right? Okay, I'll give one example. Now come back to this equation. Refer to this. Assume how many data points I have, how many records I have in this data set? 5. 1, 2, 3, 4, 5. Can we compute mean? 1 plus 2 plus 3 plus 4 plus 5 divided by, pretty clear? So can I say mean equal to 3? Online team, understand? The mean is equals to 3. Good. Now, listen to this formula. Xi minus mu. What is mu? 3. What is xi? X1, x2, x3. So can I write the formula 1 minus 3 whole square plus 2 minus 3 whole square plus 3 minus 3 whole square plus 5 minus 3 whole square divided by how many observation? Observation means every record is one observation. Are we clear? So in the same way, if I solve, can you please tell me what is output? The population's variance is 2. The population variance is 2. Are you guys clear? Mean is 3. Variance is, answer, mean is, I have a data set, guys. This data set has 5 record. I compute a mean. I got mean as 3. I got variance as 2. My question, don't you think 2 is close towards mean or not? That's called variance. 2 is close towards 3. That's called variance. Understand the concept? This is called population variance. Online team, I hope guys done. Offline team clear? Next. Here, do you see denominator, numerator, right? So denominator, we mention capital N for population. Getting my point? For sample, I'll use N minus 1. Refer to this. Now, in this case, same data. Now, let's compute the formula. Sample variance, what is denominator? N minus 1 or not? Population variance, the denominator is capital N. Sample variance, the denominator is N minus 1. So now 1 minus 3 square, everything same, 5 minus 1 equals to 4. So can I say, I write here sample variance is, what is output? 4 plus 1, 5, 1, 6, 10 by 4, which is 2.50. Which is more closer towards variance, population or sample? Guys, are you understand? When you solve these equations, I got output as 2.50. Don't be so surprised. This is very simple math. And my question, we have population variance close towards mean. Sample variance also close towards mean, isn't it? But which is more closer? Sample. Because sample, we characteristics are statistics. Understand? This concept called variance. Understand? So now go to the formula. If you refer to the formula, now look at the formula. Are you clear, guys? Sigma square, S square, population variance means sigma square, sample variance means S square. Equation is same, but here in population's variance, so y minus 1 for sample. Umakant, come on. So y minus means negative. Y plus means positive. Umakant, are you understand what my question? N minus 1, that's a formula, guys. Exactly. See what to say. Why we need to work left side? Why not right side? What is difference between left and right? Very simple. This is the formula created by your statisticians, guys. Why means we can't say that. I hope you got that, Umakant. So this is the formula, buddy. Okay. But remember, whenever, okay, many people not understand. I will explain one more time. Are you understand this mean formula or not? Now don't ask why it's capital and this and that's the formula. Population means entire record. Sample means few records. But in this data set, just to explain the concept of variance, we use a small data set so that every non-technical people can understand. Assume there are 5 students are here. All right. So 5 students, we take a mean. So when we take a mean, the mean is 3. And statisticians already written, this is the population's variance. And that's what we need to learn that. Clear? Understand, buddy? Now I hope you're clear these things. So in here, that's what to identify the difference between population sample, we can use capital N for population size and N minus 1 is sample size. Guys, are you getting my point? Everybody clear? Online team and offline team? So very simple. So population variance, and so both are spread towards mean, but sample variance is more closer towards mean. Understand? Sample variance is more close towards mean. Okay. Next one. Go to the next one. So once we compute variance, what is the next concepts? This one we completed or not? Standard deviations. What is standard deviations? Again, look at the formula. Variability, just go up. Standard deviations. Refer to this. Sigma square is variance. Which variance? Population variance. Sigma square is what, guys? Population variance. S square is sample variance. If I take root of variance, this would be my population standard deviations. This would be my sample standard deviations. Are we clear? If we take root, this become standard deviations. If I remove the root, that become variance. Guys, Umakant, are you clear? Or I will get back to you later if you have any questions. All right. See, statistics, you have some questions. That's okay. We'll try to find out. You use root of, square root of the variance is called this one. Understand? So first is variance. Second one is coefficient of, standard deviations. Then another formula is, I can just go here and write down population SD is root of variance. Explain about data. Guys, Venu, do you do descriptive statistics, guys? Calm down, man. When I explain, come on, man. When I'm trying to explain, listen and then you try to, yeah, in is always positive. Yeah. So in descriptive statistics, we got SD, minimum, maximum, standard deviations, minimum value, maximum value. So those values you get it here. Understand? So the behavior of the data, I'll get back to you this one. So population standard deviation is what, guys? Root of population's variance, and sample standard deviation is root of sample variance. So I think population mean we clear, then population variance we clear, population standard deviations we clear. I'll get back to you some of the examples now. Then the last one is coefficient of variance. Okay, guys, I'm explaining very slow. Please try to understand. Every steps I writing. Okay, every steps I'm mentioning here. Please try to digest. I mean, this part we done. Central tendency, skewness, cutoids we done. Variance, standard deviations, coefficient of variations. Understand, guys? So now I'll give you example right away. Just wait for some time. Coefficient of variation formula is what, guys? Standard deviations by mean. So SD by mean. Okay. Now let's give you one example now. So all things would be clear. Okay. See this. Assume in, let's say there are some pizza stores available in some of the cities. Let's take in US, many multiple peoples are living there or not? From Mexicans, from Indians, from different category people. And every people dollar price is different or same? It is different. For Indian, $1 is 80 bucks. For Mexican, $1 is 18.81 pesos. Understand? So assume we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 restaurants are there in New York. Assume that. How many restaurants? 10. Is it a population or sample? Sample. Because many pizza store, out of many pizza store, we bring only 10 samples, 10 store data. Guys, are you understand? Okay. Now one customer went to pizza store. He pay $1. He got one pizza. Okay. Another Mexican customer, he went to pizza store. He pay 18.81 pesos and he got one pizza. So both got one pizza. But how machines understand that? But for machine, one is less than 18.81 or not? Guys, you getting my point? What I'm trying to speak? I'm trying to speak when we build machine learning models, we need to compare all the numbers should be equal. I mean to say, I'll get back more in later. So here, so one customers went to pizza store, he paid $1, he got one pizza. Another customer from Mexican customers or maybe Indian customers, he paid 80 bucks and he got one pizza. So two pizza, $2. Two pizza, 160 rupees in INR money. So, but how do I can refer to my computer systems? How do I understand? On that case, let's apply coefficient of all the concepts now, whatever we talk about. Let's go ahead and do this first. I have a data point or not? Considered. This is one attribute. This is one attribute. Clear? Now, can I take a mean or not first? I'll take a mean of this data and I will take a mean of this data. What is mean? Average. How do I take average? 1 plus 2 plus 3 plus 3 plus. Now my question, answer me, is this data set, the denominator is capital N or N minus 1? N capital N or N minus 1? Umakant, can you respond please? Capital N or N minus 1? N minus 1. Very good. Why, guys? Because sample. Now concept clear? If it is populations, then I'll use capital N. Concept clear, guys? Okay, now let's have a look at it. So here, the mean is $C is 5.50. So I take a mean, which I got 5.50. Can I take a mean as well? Okay, we take a mean. This part clear. So first, what is the next step? Population variance or sample variance? Very good, sample variance. Online team, population variance or sample variance? Sample variance. Now for sample variance, what is the formula? 1 minus 5.50 whole square. 1 minus 5.50 whole square plus 2 minus 5.50 whole square plus 3 minus 5.50 whole square plus 9 minus 5.50 whole square plus 11 minus divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 minus 1. Can I get population variance or not? I'm sorry, sample variance. So let's go here and try. Check this. What is sample variance? S square. Are you clear, S square? Okay, S square is 10.72. Up to this 7:30 p.m. batch clear? Next. What is standard deviation? Sample standard deviation or population standard deviation? Of course, because sample variance, sample standard deviations. Now, can I take root of this data? Can I take root, guys? If I take root, now check this. 3.27, 61.59. So I mean to say, guys, isn't it? We understand mean, variance, standard deviations. Concept clear? Last part, coefficient of variations. What is the formula? Standard deviations divided by mean. So 3.27 divided by 61.59 divided by. Now the moment when you solve it, check this, what happened? Do you see both equality 0.60 to 0.60 or not? Now, even though the dollars and pesos are different, but coefficient of variations are equal. Are you guys getting my point? Coefficient of variations are equal here. Correct. That's right. So today, are you clear what is meant by measures of variability? Online team, how many of them understand? Very much understand. So how to compute mean? But I will ask one question. Right now, I have 10 records. We can go manual and solve it. But when we work in data set in organizations, we have many records or not? Would you do manually? That's why the softwares are there. What is the Python functions? .sd, .mean. Have we used this? So you no need to worry. You no need to take care of this formula. My responsibility to explain the formula so that in interview, if someone asks you, can you explain standard deviation? Would you say go and Python check SD? You can't say that, right? You have to explain. So that's the reason I need to get in detail. Understand, team? Okay. So can you please help to the correlation between them? Sashi Kumar. That correlation is I'll come back now. Wait, Sashi Kumar. Okay. Answer me. Are you clear up to this? Can I move on to the next step? Okay. Yes. Close it. So this is what variance, standard deviations. See the formulas. S square, covariance, correlations. Now the last part of descriptive statistics is measures of relationship. In measures of relationship, we have a concept called covariance. We have a concept of covariance. In EDA, we learn correlation or not? In EDA, we learn correlation. How many type of correlation? Positive, negative, and no correlation, isn't it? Positive, negative, and no correlations. In statistics, the correlation we called as covariance. In statistics, correlation we called as both are similar, guys. refer to this now. I hope Shashikumar understand now. For example, let me open to this. Okay, I'll show this graph. The two variables are correlated. House size, house price, SFT and price of both are correlevant or not? Square feet of the house and price of the house, guys. If in Hyderabad 100 square feet is 1 CR, 200 square feet is 2 CR, 300 square feet is 3 CR. Am I correct or not? So now both variables are moved together. The two variables are correlated, and the main statistic to measure this correlation is called covariance. Understand? So again, in covariance, we have positive covariance, negative covariance, and we can consider like this way. Guys, are you clear now? I think you got your answer. Okay, that's good. Close it, close it, close it. So team, in measures of descriptive statistics, we completed today. That's it. So which functions we use? Dot describe functions we are using. We are using which functions, guys? Dot describe functions. Venu, come on, guys. Correlation in EDA we called as correlation. The same concepts in statistics we called as covariance. Are you understand? Venu, don't ask single questions from here onwards. I'll unmute you, write down all the questions. At last I'll talk to you. I do see you ask a lot of bunch of questions without have any prior experience. You get in my point? Get in my point. Next one. Okay, cool. So here, so this is correlations, guys. This is covariance. Covariance is a measure joint variability of two variables. In data science, we work with data set, guys. In data set, we have attributes, variables, we have variability, positive covariance, negative covariance. This is a crystal clear document which is given by Sigma. Understand? So follow these documents, and descriptive statistics completed today. I will share this document. Can you maintain a proper formula sheets? Your author name. You are the author of the sheets. Can I share this? Okay. So guys, today we completed descriptive statistics. Today we completed descriptive statistics. This is very, I told you, this is theory, and tomorrow I'll introduce one descriptive stats practical. Okay, that's good. Now go to the statistical part, and this one also completed. This, get back to inferential statistics. Let's copy and apply here. Inferential statistics, it always deals with probability and distribution. Okay. Descriptive statistics, it deals with variables, data, all those things. But inferential statistics, it always deals with probability. So distributions comes from probability. How? Let's go ahead. I'll introduce, let me show you one documentations again. Open this, evening batch, 7:30 August, inferential stats. Okay. My question to you, a coin has how many sides? When you toss a coin, what is probability of getting ahead? 2 by 2? 1 by 2. What is probability of getting 2? 1, sorry, tail? 1 by 2, 1 by 2 or not? Okay, that's good. Now, A dice has how many side? One dice. Dice. You know, you guys called, we play dice or die, whatever it may be. So six faces, right? Six sides. So what is probability when you roll a dice? What is probability of getting one? What is probability? 1/6. What is probability of getting two? 1/6 or 2/6? Venu said 2/6. Sri said 2/6. Anyone else? What is probability of getting three? I see your responses online. Good. That's okay, guys. Okay. Even though that's wrong, you can type. That's all right. Now let's have a look at this. But before that, I want to open it in distributions. Okay. Now, okay, we call this dies or die, whatever it may be. One moment. Okay. Roll a die. Probability of getting one is what? 1/6, right? Listen to me. Getting two, 1/6, isn't it? Getting three, can we get these probabilities? Okay. Now, so there is a question. Why I'm introduced this concept? Let's see. You booked the flight ticket today. You booked the ticket for next month. If you see, you get to see your ticket is going to be 90% probability your ticket will confirm. It may confirm, it may not confirm. Probability is not equal to confirm. Sometimes it's in 70% your ticket will confirm, but end of the day, it's not confirmed. Guys, are you getting my point? So remember, but 90% problem statements are true. The behind machine learning algorithms which written by IRCTC, okay, it's absolutely true. Okay, just get back to this. Chances, that's right, chances. So if I represent, what is 1/6? 1/6 means, can I say 0.17 or not? 1/6 means what? 0.17. Now let me refer to the graph. 1, outcomes 1, 2, 3, 4, 5, 6. How many outcomes? 6 outcomes. What is a value? 0.16. What kind of distribution is this? Very good. What kind of distribution? So distributions created from probability. Are we clear? Distributions generate from probability. So my questions to you, if we roll one dice, then uniform distributions is created. Roll of one dice as generate which distributions, guys? Uniform distributions. Understand? Now my question to you, let's roll two dice. Okay. Now can you tell me what is probability of getting output as 1? Two dice has how many side? 12 side. Okay, think. Now answer my questions to 7:30 p.m. batch. So let's see the responses by online team. So when you roll a two dice, what is probability of getting 1? One second. Okay, 2/36, 1/36. Two dice. What is answer? Offline team. Who says 36/36? Okay, let's go and see that now. Okay, great. I don't think so you study math. Okay, now listen to this. Listen to me. Two dice, right? Do you see these possibilities? Okay, I mean to say, look at this pair. I have two dice. In the two dice, I'll make this die as constant. I keep rotate this, all right? 1 and 1. Now I change this 2, this become 1. I make this as constant, this die as constant. Now I change 3 1, 4 1, 5 1, 6 1. Done. Can I switch to 2 now? Switch to 2. Then 1 2, 2 2, 3 2, 4 2, 5 2. Okay, so what is my question? My question was, just have a look at this. Rolling 2 dice, the probability of getting 1 is 0. So whoever said 0, they're right, rest of them wrong. So when you have 2 dice, would you get 1? If you have 1, that's fine, 1. So guys, you got your answer? Everybody? Yes. Now, can you tell me what is probability of getting 2 now? What is probability of getting 2 now? 2, 2. Why you said 0 this time? Probability of because I have 2 dice, you never get 1, guys. You have minimum side 1 and 1, right? So now if you refer to this, now let's come back to the possibilities. The probability of how many possibilities? 36. The probability of getting 2 is 1 by 36, correct? 1 by, what is probability of getting 3? 2 1 3, 1 2 3. 2 by 36. Do you see? If you remember, we always need to count this part. I hope you study or not, I don't know, but I remember this is what they've been taught. How to compute the probability. To compute the probability, you need to do like this. I mean, if you want to know the possibilities, 3, 2, 1, 3, 1, 2, 3. So 2 by 36. Understand or not? What is probability of getting 4? Getting 4. 314, 224, 134. 3 by 36. Getting 5? 1, 2, 3, 4. 4 by getting 6. Now you understand. In 10th class, you never understand. Now you understand. Am I clear, guys? Now if you roll another 3 dice, I hope you can solve it. Isn't it? Okay. Online team, everyone clear? Online team, everyone clear, guys? Okay, fantastic. That's nice. All right. So now what is reason behind I'm explain this? Now have a look at it. Probability of getting to 1 pair or not? 1 by 36. Probability of 2 dice getting 3, 1, 2 and 2, 1. 2 by 36. So can we say 4? Now we get some probability or not? 1 by, if you divide this one, now if I plot how many side? 12 side. 2, 3, 4, 5. What kind of distribution? What kind of distribution? Normal distribution or not? In normal distributions, what we get? Mean equals to median equals to mode. Guys, I hope you clear now. So very simple. When we roll 1 dice, we got uniform distributions and it generate normal distributions or binomial distributions or binomial distributions or Gaussian distributions or bell curve, whatever you call this, or zero symmetry. This graph is so powerful. That's why this graph has multiple names, but all names relevant to same. But all names relevant to same. Guys, interesting topic, or you feel bored? Online team up to this clear, guys? Bell shape, that's right, we know. It's a bell shape and all those things. Now, inferential statistics, probability distributions. These are all concepts we plug in machine learning. These are all concepts we plug in machine learning. Okay. All right. So next, statistics I'll stop here. Tomorrow I'll continue again. And another concept is confidence interval, hypothesis testing, null hypothesis, except all there's a little tough, not tough, but don't worry, I'll make it easy. Up to this, are we clear? Let me review again whatever the topics I covered so far. Descriptive statistics, first population sample, sampling technique, inference technique. All right. Population to sample called sampling, sample to populations we called inference. All right. G test, T test. Which one T test? Sample or population? Sample. Population, G test. All right. And then we have types of data. I mean categorical, numerical. Continue, discrete, categorical. Categorical is machine learning classifications. Continuous is machine learning regressions. Discrete is machine learning clustering. Clear? Then types of data. Data measures in quality and quantity. Quality is a two-part, nominal and ordinal. We talk about 4 seasons because seasons never be ordered. In summer season also, there's a probability of raining, isn't it? So that's not being ordered. And ordinal, it's an ordered. For example, rating of your meals. Quantity, interval, and ratio. Virat Kohli scores. I mean, you can say that between the ranges. That's called interval. Tomorrow, I'll introduce this now. And ratio. I hope we done this, right, guys? Frequency, relative frequency, cumulative frequency, frequency distribution stable. Concept clear? And then population, sample done, types of data. In descriptive statistics, we discuss central tendency, mean, median, mode, skewness, kurtoise, variance, sigma square, S square, standard deviation, root of sigma square, root of S square, coefficient of variations, standard deviations divided by mean. Covariance relation, correlation called covariance. Variability between two attributes is called covariance, and descriptive statistics completed. So interview question, what is difference between descriptive statistics versus inferential statistics? Would you explain to someone? Would you explain to someone or not? Descriptive statistics versus inferential statistics. Okay. Now, one second. Did I share yesterday operator question bank? Okay. Now, I will share this document to you. Listen to this. Skewness we completed. Variability, just go home. Little open the slides. Refer to the doc. Understand, recall the concept and write it down. That's it. Go to the next part. Variance we done, standard deviations, covariance, and then starts terminology. Just little terms, I just mentioned the sheets now. Mu, mean of the population. Sigma, standard deviation of populations. Alpha, type 1 error. Beta, regressions coefficients. Theta, a general population. So just follow me whatever I said. This is just a given to make concept clear, to have no confusion about these symbols. Okay, so that's the reason capital N, number of cases, small n, sample, mean, populations, variance. So we have all those things, guys. If you can't understand, no need to be scared. Just whatever, very simply explain, guys, isn't it? Very simplified, these concepts have been explained. Next one. This is the PDF which I explain in the classes. I'm sharing you all the PDF, and also this is what interview questions, and please refer to the interview questions. And I'll start interview questions as I'm giving Python. Now statistics are given. Do not give to anyone. You not get any questions out of the box in interview. Just trust my words. Are you clear, guys? It doesn't matter how do you explain to your recruiter or interviewer, it's all depends on you, but we'll cover it one by one. We will cover it one. I'll share all these documents to you, And today we introduce inferential statistics, which I already, this is what inferential statistics. Okay, distributions. Do you see uniform distributions, right guys? Or binomial distributions or student-t distributions. We'll come back all those things. Okay. Now statistics, I'll stop here. If I tell, everyone feels sleepy. Let's go ahead and we go to another topic. Okay, where is that? It's completed and we done this. Okay. Interview questions for conditional statement. Okay. Python conditional statements you learned. I already explained. This is documentations. If the test expression is true, get into the if body and then statement. So this is all the details we already, you know that, but for a document, I have to share you. So this is the proper file I shared. This is for explanations and read this explicit functions. If else Python using list compressions. In this example, we are using Python else if in a list comprehensions that odd, then a digit sum will be stored, else not. Now, I hope you can understand. Define functions, I will introduce now today, and slowly we go to the functions. Nested if, did you know this, guys? Please follow this flow diagrams. If not understand, leave it, no worries. Okay. If you understand, that's good, no worry. But main focus is to questions. Is this questions, answers? Yeah, questions. Let me open this. What is conditional? How many sections? 2 to 3 sections I created. What is conditional statements in Python? Explain. See, interview encountered these questions, guys. If you apply for a Python developer, they don't ask any questions. No worries. You don't need to go with any hacker rank, all those things. Simple program solve. Tomorrow, when someone asks these questions, what your response? If you prepare now, tomorrow you speak. Am I correct? If you see today, tomorrow you can speak, guys. Just that's it. You don't do any hard work. Just follow my classes, follow the notes, follow the practical, spend 4 days, then enjoy. Then attend the practical, attend the interview. Every day, take one interview. By the time batch completes, you will close. And you say, sir, thank you. That's it I want from you. Are we clear? Next one. How do you write a basic if statement in Python? Will you write? लिख पाओगे कि नहीं? And then what is the purpose of indentations in Python? Okay. How do you use the elif statement in Python? Simple questions. Okay. Now section B. What is Python? What is key? What is PEP 8? How memory managed in Python? How memory managed in Python? What is difference between shallow copy and deep copy? How do you handle exceptions? See, the questions which you not understand, don't worry. When you try, just put a red mark. After a few days, open the file, things would be pretty clear, because what is purpose of self? I will explain in oops, not right now. Okay. Whatever questions you understand, you can do it. What is module in Python? Section C. Describe Python loops. That's it. A few questions. You want it or you don't want? Okay. Explain the concepts of iterator. When you write a for loop, behind the scene, it call iter and next. But in generator creates iterator. In defined functions, we have yield statement. Those are the big topics. I don't introduce now. Can I share this? This is the question, and this is the answer. So is this fine now? Question and answers. I will share all those things. Just go ahead. And 1, 2, 3. I will share this, guys. Just go to the class notes now. Okay, this is also I will share. Statistics interview questions document. Can you prepare the formula, guys? Everyone? Now, one moment, little scroll down, then coding and interview. Number 5, conditional statement. Loops, I'll give you another one. Do you want me to maintain like this? Yes or no? For next 5 months, 5.5 months. Okay, fantastic. Now, can we start functions now? Python functions. Functions are divided into how many? Okay, but let's go back and let's start today. All right, just kernel. Listen to me. I know because for experienced people, this is don't want, but for 90% are just newbies. So that's why we just have to. Why do we need functions? Let's understand one scenario. You might be working simple or complex projects. Let's assume in organizations, we work simple projects or complex projects. Understand, guys? When you work on complex project, so complex project has to break down to small task or not, isn't it? When you talk about smaller task, of course, you need to write multiple statement. You need to write multiple statement. See, in the routine work, same work we do multiple times or not, isn't it? If you want to operate payment operations, in that you need to write multiple statement, guys. So all the statement of the task are stay together and you create a functions and reuse later. So you can define a statement and once you define and reuse later. For example, functions are divided into how many type, guys? Functions are divided into 2 type. The first one is inbuilt and second one user defined. So inbuilt functions, we have many like print, and remember every functions ends with open bracket, close bracket with colon, and by default 4 spaces, indentations by default 4 spaces. Conditional statement also colon and 4 spaces in Python. Just go here. 2 main property of the function: define the function, call the function. Okay, so just go here. First, user defined function always start with def keyword. Understand, guys? User defined function always define with def keyword. How many keywords we have? 35 to 36 keywords, because as per the the system up 3.10 versions. Now the two main properties of function, two main property of the function. The first property is def the function, or let's say I want to greet, and then call the greet function. Guys, are you clear? Let's go ahead and look at this now. Listen to me. And first, what is difference between variable functions? In variable, we don't assign open bracket close, but in functions, we do it. Define greet. Okay. What is name of the functions I created? Greet functions. Is it inbuilt function? Greet is inbuilt function. Yes or no? No. And how do we greet to each other? Hello, good evening, good morning, good noon, good night, isn't it? So here, functions are nothing but collections of statement. Just go here. Let me write it down. Functions is collections of statement. What statement? Print statement. For example, greet, hello, good morning. I define a function Why I didn't get output? I didn't call the function. I have to call it or not? Because see, we define a greet function and we print a message, but I not get output because I didn't call it. So the moment when I greet here, so I define a function, write some statement and call the functions, boom. Hello, good morning, isn't it? Are you guys clear? Now there are 4 persons are there. You have to say 4 times good morning, all those things. So how many times I called? How many times I called, guys? Only 2 times, right? I want to call another 2 times. Just copy and here, oops, and here. So now what happened? If I execute, team, are you understand offline guys, everyone, non-technical guys? What is the syntax? Define the function, write a statement, call the functions. Now, let's say you have 4 friends. Would you say 4 times good morning or not? But in this case, wait, Sushma, calm down. Yeah, you know that's fine, but I will explain to my other students as well. So if I define greet functions, how many times statements I generate? Now 4 times or not? Clear? Now let's copy and again, how many times? 6 times. But don't you think the code is too lengthy? The code is too lengthy, guys. So the beautiful part of the function is you write a statement once, you call the functions so that you get the statement repeats. I mean to say, rather than I like this way, okay, so rather than I can write this way, can I write this way, guys? See, greet, and how many times I define a functions once, call how many times? So 2 times, how many statements I generate? Now 4. This part is clear or not? Now if I write greet, how many times? So if I part greet, how many times? Guys, are you clear? So the beautiful part of the function is once you define reuse later. So once I define the statement, am I reuse multiple time or not? That's the beautiful part of the functions, guys. And I need a gap in between. Just try to type print and then try to type print. Cool, you got a gap now. How many of them clear? Online team, offline team? Everybody understand? I'll make you king in Python. Oops. Oops class, I will tell everyone to, I will send you the code, you work with me. You has to be developer and very soon. Don't skip single sessions. Louder and clear. It doesn't matter your CEO, CFO, leaders, founders. All right. Guys, are you clear? Okay. Next one. No, actually, no. Actually, if you don't know the functions, you don't know methods. You can never write methods, class, oops, all those things. Just go ahead and let's do this. So let me repeat again. Let me repeat again. Two main property, define the function, call the function. The beautiful part of the function is once you define a function, you reuse later. You no need to write same thing multiple times. Understand, guys? Because in the memory, when you reuse, memory less space it takes. Got my point? Next one. Create function, then define the function, call the functions. Good. Now, if you want to call this statement 2 times, just define the functions once, call functions twos. Are we cleared so far? Okay, this part. Let's create another functions. Add. My question, in this function, did I pass any argument? Yes or no? No. What is meant by argument? Family has dad and mom. Another family has dad, mom, son, kid. Remember, 2 arguments, 4 argument. Entire AI, I'll give you this example. Because of this example itself, my students are clear in interview. Team, okay, now follow this. So functions with argument, functions without argument. Let's get back to the point.